When we think about AI, we usually picture code, computers, silicon chips, right? But what if I told you the real story, the untold story, has a lot more to do with ants and evolution? Yeah, the AI revolution actually started way, way before the first computer was even plugged in. It feels like society is having this massive Control-Alt-Delete moment, doesn't it? Like we're hitting a giant reboot button, and AI is the one driving it. And this thing is moving at a speed we've just never seen before. But here's the thing. To really get a handle on where this is all headed, we've got to look beyond the slick chatbots and dig into what's really going on underneath. So, if we want to understand the future, we have to go all the way back to the beginning. We need to find its original source code. And you might be surprised to hear that that source code wasn't written on a keyboard. Nope, it was written into the DNA of the world all around us. It turns out the very first AI engineers, they weren't computer scientists at all. They were actually biologists, just people observing the incredibly smart, efficient systems that have been running on this planet for millions of years. See, the whole point of AI in the beginning wasn't to invent some brand new kind of intelligence out of thin air. No, the goal was to copy it, to mimic it, to take the logic of living things and just capture it in math. From day one, this was all about reverse engineering the genius of nature. And I mean, they looked everywhere for ideas. They saw the way neurons fire in our brains and thought, hey, let's build that. And boom, you get neural networks. They watched how a colony of ants always finds the most efficient path to food and use that to build optimization algorithms. It's incredible, right? The blueprint was right there in front of us the whole time, hidden in plain sight, in our own DNA, in the way birds fly, everywhere. And really, it all came down to two super basic Darwinian ideas. Rule number one, find food, and do it efficiently so you survive. Rule number two, reproduce. Pass on your best features to make the next generation even better. That's it. Those two simple drives for survival, they became the mathematical engines that powered the first wave of AI. Okay, so you might be thinking, if these ideas have been around for decades, why is AI blowing up right now? What changed? Well, the answer wasn't another breakthrough in biology. It was something completely different, a massive shift in our digital world. The real game changer, the spark that lit this whole fire, wasn't a new algorithm. It was the explosion of a brand new natural resource, something we started generating in unbelievable quantities: data. For a long, long time, AI was really good with neat, tidy, structured data. Stuff that fits perfectly into a spreadsheet. But then came the internet, and with it, this tsunami of messy, unstructured data. We're talking photos, YouTube videos, random blog posts, everything you say on social media. The old AI models, they were built for a quiet library. They had no idea what to do in this loud, chaotic, sprawling digital city. And that's where deep learning comes in. Funnily enough, it wasn't a new idea. It was basically a souped-up version of those neural networks from the 60s, an idea that had been kicking around since the 90s. It was like the perfect tool, just sitting on a shelf, waiting for its moment to shine. And suddenly, with all this data to play with, it could finally start making sense of all that messy, human stuff online. Okay, so now we have the models and we have the data. But there was still one more piece of the puzzle missing, a really, really expensive piece. Fast forward to 2017. A team of researchers at Google drops this bombshell of a paper. And in it is the blueprint, the actual architectural plan for the kinds of large language models we see today. The engine inside things like ChatGPT. And just like that, the secret was out. The plans were public. So here's the big question. If the blueprint was out there for everyone to see, how come only a few big companies were able to turn it into world-changing tech? What was the secret ingredient? What separated them from everyone else? Well, it turns out building a modern LLM is kind of like following a recipe. Step 1, you take the architecture, the transformer. Step 2, you add a truly mind-boggling amount of data. We're talking like scrape the entire internet. Step 3, you hire an actual army of people to clean and label all that data. But the last step, the secret sauce, is just brute force. A staggering, almost unimaginable amount of cash for the computing power to process it all. And that final ingredient, that's the real barrier. And this total dependence on money, on massive funding, has kicked off this insane high-stakes global race. So let's break down what that actually looks like in the real world. So check this out. According to Professor Arpan Kar from IIT Delhi, the amount of money available for AI research in places like the US and China is somewhere between 20 and 30 times more than what's available in a country like India. That's not just a gap, that's a canyon. And that funding gap is a huge, huge problem. Why? Because the price tag on the essential gear, the super powerful servers, the cutting edge chips, it's pretty much the same for everyone. No matter where you are in the world, it's a global market. So if you're starting with 20 times less cash, you're already at a massive disadvantage before you even begin. This money difference ends up creating two totally different ways of thinking about innovation. In one ecosystem, you've got so much cash, you can afford to take these huge, crazy risks, these moonshot projects that have a high chance of failing. But in the other, you're forced to play it safe, to focus on short-term projects that you know will deliver a result. The freedom to try something wild and fail, that becomes a luxury most just can't afford. So, with all that in mind, given this reality, where should we be focusing our energy? Whether you're a country, a company, or just you, the answer might not be what you think. This is where we get to the real race. Because maybe the race isn't just about who can build the biggest, most expensive models. Maybe the real competition is about who can learn to use these tools the best. I mean, trying to win the money and hardware race, that's a tough, expensive game to play if you're starting from behind. But winning the literacy race, now that is a whole different ballgame. And this is exactly Professor Carr's point. He argues that maybe the smartest investment isn't just throwing money at competing with hardware. Maybe it's about empowering people, giving them the skills to get the most out of the amazing tools that are already out there. I mean, think about it like this. Back in the 80s, the big new skill was computer literacy. That gave you an edge. Then in the 2000s, it was digital literacy, knowing your way around the internet. Well, today, the new essential skill is AI and data literacy, knowing how to use these tools, how to talk to them, how to use them to make better decisions. That's the new baseline. So here's what it all comes down to. The incredible power of AI isn't just in the hands of the people who build it, it's in the hands of everyone who learns how to use it. Everyone who learns to ask smarter questions and find brand new answers. So the real question isn't just, what can AI do? The real question is, what are you going to do with it?